we're going to start talking about how to get a quadratic function that does not appear to be in vertex form or in transformational form. Close this door. And how we're going to make it reveal its transformations to us. All right, this is technically called completing the square if you look at this stuff, but completing the square is like a bad word with a lot of Algebra 2 teachers and then a lot of Algebra 2 students, and it's not as hard as people make it out to be. All right, we have this, it is hiding its transformations. So I have to work it a little bit to help it reveal it. There's 3 steps, that's all it is. I start off by, I'm going to factor. So first I want to find the vertical stretch, shrink, stretch, shrink, or reflections, which is always going to be whatever that first term is. So I want to get that. Since it's a vertical transformation, it's always going to be a vertical transformation. I'm going to pull it out so that I get it isolated. There's a bell, all right? I'm not going to factor it from the whole thing because I don't like doing lots of math. I'm only going to factor it from these x guys, all right? I'm going to get it because right now it looks like it's a quadratic and a linear. I don't want that to be like that. I want to just show you a quadratic. So I'm going to take this 2 out, all right? Factoring is good. 2 from 2x squared is going to leave me an x squared, and 2 from negative 8 is going to leave me a negative 4x. All right, and now I've got that. Now I have to find out what type of horizontal thing we have going, because obviously I have some in parentheses, there's something horizontal happening in there. I have to find out what it is. And in order to find out what it is, check this out. It's always going to be, we have a good color here. It's always going to be half of that number. Just is. All right. So I'm going to make this into a square. I don't want it to be linear and quadratic. I want just a quadratic. All right. So I'm going to have an x, and I'm going to have minus 2. That always works. That's always going to be the horizontal in there, right? Now I have to do a little bit of analysis. I have to see what I have and what I need. Okay, I need to have the exact same thing here on the end the whole time. I need to not change that number. I need to always have 6 at the end so I can find out what my vertical shift is. So I need to have positive 6. But I got to see what I already have because I know there's a number in here kind of halfway in. And in order to find out what I have, I cover up the x and see what I have for my regular numbers already. So if I cover that up, I have 2 times negative 2 squared. So follow basic order of operations. Negative 2 squared is 4 times 2 is 8. So I already have 8, but I need to have 6. Well, if I have 8 and I need 6, I need to lose 2. So subtract 2. And now I have my big full transformations. This graph right here, this guy, is the quadratic function, right? He's been stretched by a factor of 2, so he's really skinny. He's been moved 2 spots to the right, 1, 2, and 2 spots down, 1, 2. Of course, I'd be like right here in the middle of this. So that's its vertex, and it goes up twice as fast. That's 2, right? Yep. He's a skinny quadratic, like that. That's it. Those are the 3 steps. I'm going to do it again, just because you want to see it. There's something different. So watch the 3 steps again. Let's go with negative 2 this time. X squared minus 8x minus 5. Okay, so watch, 3 steps. Step 1, I have to pull out the vertical stretch or shrink and reflection. I have to pull all that vertical stuff from the front. So I factor out this guy. That's a negative 2 just from the x's. I got to get that away from the x's. Right? Negative 8 divided by negative 2 is positive 4. Factoring is just division without losing what you divided by. And then that minus 5 is still out here. That's step one. Factor out whatever's in front. Step two is to get our horizontal shift nailed down. So when we get down to the horizontal shift, that guy's going to just be regular x, and I'm going to have half of that. Always half of that number. And that shows me my horizontal shift. So I've got my vertical stretch or shrink, I have my horizontal shift, now I have to see what the vertical shift is. So I see what I have and what I need. I need this guy over here to be -5. I have the x. 2 squared is 4 times -2 is -8. So if I have -8, but I need -5, I have to change that, and I need it, well, let's say need. I'm going to put in and add 3, because -8 plus 3 is -5. So now I have it in vertex form. My graph goes down, it's been reflected vertically, stretched by a factor of 2, shifted 2 spots to the left, because your x is a liar, 1, 2, and then moved up 3 spots. So 1, 2, 1, 2, 3. There's my vertex, and it goes down 2 spots. 1, 2. That's my quadratic. That makes sense? You math nerds are like, oh, hey, did he really change the value of anything? I can always go from here back to that by literally squaring everything out. X plus 2 squared is x plus 2 times x plus 2. Watch, it's like magic now. First comes first, x squared, outside 2x, inside 2x, last and last is 4, right? That becomes x squared plus 4x plus 4, but all of that would be multiplied by -2. So that gives me -2x squared minus 8x minus 8 plus 3. See exactly, it's all the same pieces all working. And -8 plus 3 is -5. And now I'm right back where I started. So it is the same thing. That's how you complete the square in 3 steps, or how you go from standard form to vertex form in 3 steps. Factor out the a, find your horizontal transformation, analyze and decide what your find your horizontal shift, analyze and decide what your vertical shift is. And then you are done. 3 steps.